Uh, so today we will start with tries or try data structure. So let's see how a try data structure looks like. So try data structure is like a tree, but which this I want to show means try data structure. We will pick this question to understand what does a try data structure means. So try data structure is a kind of dictionary, means it is used for storing strings, and then we can efficiently search that string in the try data structure. So try data structure, in the suppose we have in our string only lowercase English letters, so in that case our try data structure node will have a array of 26, means node will contain 26, array will contain 26 try nodes, means representing from 0 to 25, representing A to Z. Can take example like so in this question we have to implement the try data structure. So is a data structure used to efficiently store and retrieve keys in a data set of strings. There are various applications of data structure such as autocomplete and spell checker. So it is nothing but a data structure to store strings and retrieve them faster. So we need to implement this try data structure where we have insert function. We need to insert into our try data structure. Then we have search function. We need to check if a particular string which is given as input whether exists in our try or not. Then we have a start with function where we will be given with a prefix, and we need to check if this prefix exists in our try or not. So in this photo, in this image, suppose our string contains 0 to 9 digits. So this is our first node. So let's say we need to store number 1 2 3. We need to store string 1 2 3 in try data structure. So first in this node we will mark this one as true, and now this one will point this array. In this array we will mark 2 as true, then this 2 we will point another, let's say this node, and we will mark here 3 as true. So in this way we will store something in our try. And then suppose we are asked to find 1 2 3, then what we will do, we will see if we will start from this head node, and we will see if 1 is true. Yes, 1 is true. Then we will follow one's node, one's pointer, and we will go here and we will look for 2. Yes, 2 is also true. Then from 2 we will go to 2's next node, So next node will be this, and in this node we will check if 3 is true. Yes, 3 is true. Then we can say all the characters we have found, and we can return true, that this uh, means data structure contains a particular string. Okay, so let's first implement our try node. So let's initialize a class try node. So as I have said, our try node will contain uh, here we have a case of we will only have lowercase letters, so it will only contain 26 try nodes. So we will have a array, means our current box will point to a array of let's call this children of size 26. And this try node will also have a value, or we can also have a boolean to mark as true or false, mark it as true or false. We will initialize this value as 0. So this is our try data structure. So let's initialize this try data structure. Try node head, and this head will be equal to new try node. So what we are initializing, we are initializing a head, means we are initializing this try node having value 0 and having children's these children's, means this node is pointing to containing this children, and its value will be 0. So now we need to insert a word into it. So we will insert it these words every character into our try. So current character will be this will be current character, and we need to insert it into our try. So let's initialize a temporary iterator node. So we will use this temp to iterate our try. So what we will do, we will access our head nodes children head temp dot children, and in this children we will mark our in this children, we will put a node, a new try node at this position, current minus a position. We will put a new try node. Okay, so how we can use this value also, means we can also avoid using this value, means let's say for now what we will do, we will mark our temps value as temp dot children dot value as means we are putting characters value in our children's value. Okay, so then what we will do, we will move our temp to temp dot children minus a. Basically we are moving temp to the next pointer. So this way we have inserted our word into our try. Now we need to search our word in our try. So what we'll do, we will again initialize a temporary node at head position, and we will iterate our word. Again we will iterate our word, find current character of our word. Now we will check if our this temporary variables children's this position is null, then we can say this string doesn't exist, means when while inserting we are at temps children we are putting we are initializing it with new try node, and while searching if at that position means we haven't initialized, that means it is null, so we can say that it doesn't exist in our try. Otherwise if that exists, then we can move our temp to its children, current minus a. And at the end, when we have found all the values in our try, we can say we have found our word and we can return true. Okay, I think we can use our value to mark a word, means we have found a word. uh, Means while inserting we can add it to the last node -1, that at this position our word ends. So I think instead of putting this value as -a, what we can do is we can put temp dot value as -1. So it will help us to identify that at this position our word ends. And we can return true if our temp dot value equals to -1. Otherwise we can return false. Means this indicates that our word is ending here. And in the case of prefix, what we can do, we don't have to find the full word, we just have to find prefix, so we can remove this condition. Suppose we want to insert ABC into our try. So what we will do, first we are at A position, so we have initialized our head. So in this children we will put a node. We have put up a node at 0th position. In children, and then we can move to this node in children. We have moved to children. Now we are at B position, and we will check. We will add at B position a new node, and then we will move to that node. And then we have C. Then what we will do, we will insert a node at C position. Current will be C, so we have added a new node, and we will move to that C node. This will be something like, initially we have head. So in head what we will gonna have, in head we will have two variables. One is value and other is a children node, a children array. And suppose we want to insert ABC into our try. So what we will do, we will in this children, which is initialized here, we will put up a node at this position, 0th position, and then we will move our temp to this children's 0th position. At 0th position we have inserted a new try node, which means we have inserted a new try node, and this will move to okay. After inserting we have moved to this position. and then we will move to one position after inserting B. Then we will move to children to this position, and at this position we will add in value we will put -1, indicating here our word is ending. And similarly, in order to search the word, we will see if our current -a is null or not. So it's not null, means 0th value is not null. Then we move to this value. Then we will check if its children 1 is not null. No, it's not null. Then we will move to it, and then in its children we will check if its 2 value is null. So it's not null. We will move to children of 2, and we will check if its value is -1. Yeah, it's -1 a word, and here we will return true, else we will return false. So let's see if this works. Okay. We have prefix here instead of word. Okay, so our first case is working perfect. Let's see our previous submissions. So we only have a one submission in 22. So how we can go for another test cases? Let's say we add a test case, insert, search. Let's say if we add here double E. Let's try to submit this. Okay, we are getting error. We are inserting app, then apple, then inserting beer, add jam, rental, apps. Then we are searching apps. So we haven't found apps. We are returning false. Then we are trying to find app. So we are returning also false here in the case of app. So we can modify this test case something like let's see. Let's run this test case. Okay, so we are getting wrong output. Let's debug it. So first we are adding app to our try, means we have initialized our try and we are inserting app into it. So what we will do while inserting, we will insert a new node in this place, A's position. Then we will move to our temps children, which will be a new try node. And in this new try node, then we move to next character P. Then in this new node's children, we will add P. Okay, we are inserting a new node every time. So we should only insert node if it doesn't exist. Means if temp.children of current minus a is null, then on in that case we should only add a node. Otherwise our object will reinitialize, and instead of -1 it will replace it with 0. So I think that was the issue. Okay, let's see our this part and try to run this. It's now working. Let's try to submit this. Okay, we have a submission. So I think we have just copy pasted code everywhere. So knowing this structure means, if here we are using 26 size because we have only lowercase letters. Depending upon the input type, we can have many childrens. So try data structure is a tree of nodes basically. So I think so to understand try data structure means in deep, we can look for this link, which is Wikipedia link. So here try is explained. So this is how a try works. Means we have these letters, let's say 26 letters. So this is S. So S will point to this. Now in S children we have E and H. So if we follow this word S, H, then E, she, then this means this data structure holds a word she, 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 and also S, E, and what's this word? I think it is A, B, C, D, E, F, G, H, I, J, K, L, L. Okay, so S, E, L, L, cell, and then this goes to S, cells. So this word is also present, SHE, SELLS, cells, and SEAC. So this is a try data structure. Okay, so this is it in try data structure. We will implement other questions using these data structures. Okay, that is it for today.